Good morning, dear students. Here I am, Priti Sharma, and I will be taking your online lectures on database management systems. I will start with Unit 4, and today I will discuss with you a very important topic of Unit 4, that is transaction processing. Now, let us start with what a transaction is. A transaction is a logical unit of work of database processing that includes one or more database access operations. Or, in other words, we can say that a transaction is an action or series of actions that is carried out by a single user or application program to perform operations for accessing the contents of a database. These operations can include retrieval, insertion, deletion, and modification. Now, a transaction must be either completed or aborted. A transaction is a program unit whose execution may change the contents of a database. It can either be embedded within an application program or can be specified interactively via a high-level query language such as SQL. Now, if the database is in a consistent state before a transaction executes, then the database should still be in a consistent state after its execution. Therefore, to ensure these conditions and preserve the integrity of the database, transaction must be atomic. Now, atomic transaction is a transaction in which either all actions associated with the transaction are executed to completion or none are performed. I will explain the concept of transaction with an example. Suppose you are working on a system for a bank. A customer goes to the ATM and instructs it to transfer rupees 1000 from savings to a checking account. This simple transaction requires two steps. First is subtracting the money from the savings account balance, and second is adding the money to the checking account balance. Now you have to consider what would happen if a machine crashed between these two operations. The money has already been subtracted from the savings account, will not be added to the checking account, and it is lost. You might consider performing the addition to checking account first, but then the customer ends up with extra money and the bank loses. The point is that both changes must be made successfully. Thus, a transaction is defined as a set of changes that must be made together. Now, a transaction can be in one of the following states. There are 5 states. First is active state, partially committed state, aborted state, committed state, and failed state. First one is active state. Now, when a transaction starts its operation, it comes under the active state. Second is partially committed state. Now, when the last state is reached, then transaction is said to be in a partially committed state. Aborted state. After the transaction has been rolled back and the database has been restored to its state prior to the start of the transaction. Fourth state is committed state. Now, after successful completion of a transaction, it comes under a committed state. And last is a failed state, when the normal execution can no longer be proceeded, then it is a failed transaction. Now, there are 4 properties of transaction which are known as acid properties, and these properties ensure that a database remains in stable state after the transaction is executed. These 4 properties are A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. First is atomicity. Now, the atomicity property of a transaction requires that all operations of a transaction be completed. If not, the transaction is aborted. In other words, a transaction is treated as single individual logical unit of work. Therefore, a transaction must execute and complete each operation in its logic before it commits its changes. Second property is consistency. Database consistency is the property that every transaction sees a consistent database instance. In other words, execution of a transaction must leave a database in either its prior stable state or a new stable state that reflects the new modifications made by the transaction. Now, if the transaction fails, the database must be returned to the state it was in prior to the execution of the failed transaction. If the transaction commits, the database must reflect the new changes. Third property is isolation. Isolation property of a transaction means that the data used during the execution of a transaction cannot be used by a second transaction until the first one is completed. This property isolates transactions from one another. In other words, if a transaction T1 is being executed and is using the data item X, that data item cannot be accessed by any other transaction T2, T3 up to Tn until T1 ends. Last property is durability. It states that the changes made by a transaction are permanent. They cannot be lost by either a system failure or by the erroneous operation of a faulty transaction. When a transaction is completed, the database reaches a consistent state, and that state cannot be lost even in the event of systems failure. Durability property is the responsibility of the recovery subsystems of the DBMS. Now, there are several reasons for a transaction to fail in the middle of execution. Some of these can be computer failure, like a hardware, software, or network error occurs in the computer system during transaction execution. Next can be a transaction or system itself, like some operations in the transaction may cause it to fail, such as integer overflow or division by zero. The user may also interrupt the transaction during its execution. Next can be local errors or exception conditions detected by the transaction during transaction execution. Certain conditions may occur that necessitate the cancellation of a transaction. For example, insufficient account balance in a banking database may cause a transaction to be cancelled. Next can be concurrency control enforcement. Now, this method may decide to abort the transaction because several transactions are in a state of deadlock. Next is disk failure. Some disk blocks may lose their data because of a disk read-write head crash. This may happen during a read-write operation of a transaction. Now, last but not the least, there can be physical problems or catastrophes. These refers to an endless list of problems that include fire, theft, etc. With this, I end with my today's lecture. Thank you.